All right, everybody. Um, Welcome. In this chapter, we're going to cover web security, web servers, web applications, and SQL injection attacks. These topics are critically important because most modern attacks target web-based systems. And so we're going to look at how attackers think, where vulnerabilities come from, and what defenders can do to reduce that risk. Let's take a look here at web servers. So that's where we'll start. And just a brief overview is that a web server's job is going to be to deliver content to users, but every servers, every service exposed to the internet increases the attack surface. So understanding how web servers work help us understand how they're going to be attacked. So in this section here, the hands-on skills focus on identifying web servers using Nmap and capturing credentials using Wireshark. These exercises are going to model real-world reconnaissance attackers will perform before launching bigger attacks. So the extraction of the web server information from Nmap and when you crack FTP credentials with Wireshark. One of the key terms that we need to understand before we move forward is web application. And this term will come up repeatedly throughout our chapter. But what is it? A web application, most of you probably already know this. A web application is software that has been installed on top of a web server. Unlike static websites, web applications process user input. They interact with databases and make decisions, which makes them powerful, but also dangerous if poorly secured. And so the next couple of slides here are going to be diagrams to show how attackers approach web servers. The main takeaway here is that attackers don't start by breaking in. They start by observing, mapping, and probing for weaknesses that already exist. So we've got our TCP request, our TCP connection. You can see the connection is now established. A HTTP request from the URL, and then the response from the web page. So yeah. Now, Microsoft IIS uses models to extend functionality. Well, while modules provide features like authentication and database support, each enabled module is also a potential attack, an attack vector, if it's outdated or if it's misconfigured. So the IIS modules of database support, authentication support, certificate support, security support, and process management, as well as protocol listeners, um, is a potential attack vector, like I said earlier, if it is outdated or if it is misconfigured. The Apache modules, they use a similar approach. Features like um, SSL, logging, intrusion detection, they're helpful, but unnecessary modules should always be disabled to reduce risk. So authentication, SSL support, TLS support, enhanced logging, intrusion detection, HTTP request filtering, and proxy support for the Apache modules there. I'm going to give you a couple visuals to reinforce that attackers follow a structured methodology, not random guessing. Most successful compromises exploit weak configurations rather than advanced hacking techniques. So just a few visuals here that help you, right, help you understand that attackers follow that methodology, right? We got a little guy here with a, don't come in here on his mobile phone, little idea there. A three section here password, super weak configuration. It's not a very strong one, and I'm sure that could be easily guessed, whatever it may be. Rolling out the red carpet for them to come right in. It's just we don't have to be these hackers from the movies sometimes to get into systems. Sometimes the misconfigurations, sometimes the weak configurations are really the easiest way to get in. Um, so anyway, let's talk about some common vulnerabilities real quick. Common vulnerabilities are going to include default passwords, unnecessary services. They will include excessive error reporting and weak SSL certificates. These issues exist because of convenience during setup and failure to harden systems after deployment. So these are some of the most common vulnerabilities that you will see and that you'll need to be on the lookout for in your ethical hacking here. Default passwords, really weak one there, right? It's common though. Okay. Um, let's look at a couple different attack paths against web servers. And please keep in mind that attackers often chain small weaknesses together rather than relying on one single flaw. So they're going to stack them if they can. But let's look at a couple different web server attacks. We got this, kid looking all sad here. Um, you know, just a few visuals to help. Let's just quickly. Oop, yeah, keep it moving here. Okay, so what is the web hacking methodology? Well, the web hacking methodology is to start here by information gathering, footprinting, mirroring websites, vulnerability scanning, session hijacking, and password cracking. So this methodology is going to reflect how attackers move from information gathering to exploitation. Defensive security teams use the same methodology when performing penetration tests. Okay. Um, so you think like a hacker, essentially. Misconfiguration is one of the most important or most common, causes of breaches. So this plan configuration, plan accounts, plan permissions, plan restrictive policies, and test configurations, right? With proper planning, testing, and documentation, this is going to significantly reduce the risk of accidental exposure. So we want to avoid the misconfigurations. We want to plan it out accordingly, be thorough, be meticulous, and that way you won't make these mistakes and leave your web servers open for attack. Or if you are the ethical hacker, the penetration tester, you're going to look for some of these things, right? Is it a misconfigured system, right? What about the accounts? Can I get in some privileged accounts? What are my permissions, right? What are the restrictions? What are the policies? So just to think like both sides of the coin, white hat and black hat. These countermeasures will focus on reducing attack surface, monitoring activity, and responding quickly when vulnerabilities are discovered. So we got a little tent with a hole in it. We patched it before the bees came in, right? So if we respond quickly, we should be good. But that leads me into patch management. Patch management must be intentional. Applying patches blindly can be dangerous, but failing to patch also leaves known vulnerabilities exposed. What's your risk tolerance, right? So we want to verify the source of the fix. We want to research the fix. We want to apply only as needed, right? If we don't need that patch because it's early on and there's going to give us more vulnerabilities with that patch, then that's something to consider. So you just need to work in tandem with your team to figure that one out. All right, let's move on to user accounts. In user accounts, we got to make sure that we remove inactive accounts, remove default user accounts. Big one you've heard time and time again is to grant the principle of least privilege, so least possible permissions. Unused accounts are like low-hanging fruit for attackers. Least privilege access is one of the most effective security controls that we have. So if we have an unused account, but it also has the least amount of privileges there. Even if they're able to get into that unused account, they maybe can't get anywhere else, right? So they hit a dead end. But if you leave a privileged account open and it's an unused account, now we have a problem, right? So we want to just keep that in mind as we're progressing through here. All right, that goes into files and the directory. So we want to disable directory listing options, remove non-web files, filter user input in our web servers. Directory listing and poor input filterings have caused countless breaches that we know of. If users don't need access to the files, they shouldn't exist on the web server. Okay, so let's just keep that in mind. Moving right along, we've got some images that summarize layer security. No single control is perfect. Defense in depth. You've heard that probably before. But multiple overlapping controls significantly reduce success rates for attackers. So we've got the bank, we've got an agreement, a handshake for the money, right? We've got the vault inside the bank that houses all the nice gold coins, like we're in Gringotts or something. So the user goes to one bank, but then that bank sends money over to another bank, right? So we've got no single control. Um, if we left all the money in one bank, that would be an issue, right? He robbed the one bank, then it's all done, right? So there's not some security there. Well, the same thing can be applied here in your networks, right? You want to access the web server from the network, but here's the server. It's got to go through a firewall to get to another network. You got some defense in depth. So as you progress through chapter 12, you've got these in-class labs. They're going to reinforce everything we talked about prior to this. You'll practice identifying web servers and observing how credentials can be exposed on the network. So you'll extract the server information within MAP and then crack the credentials with Wireshark. Pretty fun labs for you to practice there in our CompTIA test out. But while I have you, and we've only gone in for about 12 minutes or so, maybe start thinking about some of these in the class discussion. If we were face to face or whatever, then you could, we could discuss it together. But what's a web application? What are they, right? That's a pretty simple one. What are the steps in the web application attack methodology? What are the steps in web application pen testing? Right? What are some measures that you can take to help prevent web application attacks? So they'll help you connect technical concepts to real world security decisions. And just be sure that you're paying attention to those. Okay, let's go into 12.2, which is going to be talking about web applications. This section skill overview is going to be talking about performing hidden field manipulation attacks. You'll exploit something called cross-site scripting vulnerabilities, very cool, and then scan a website with a Tunix. Key term, again, web server instead of web application. So a web server is a server that is a computer used to store and distribute web pages to clients. It's not anything fancy, and I'm sure you're aware of this, but it could literally be a laptop. It could be a Raspberry Pi. It could be just an old desktop computer, maybe no monitor connected to it at all. But that would be a web server. Web application types, you've got your browser-based web apps, you've got mobile applications, and client-based applications. So these three are different. Most commonly used, I guess, now between the mobile, which mobile and browser-based are pretty similar, but those are two of the most common applications. And then depending on, your job functions or whatever, that could be client-based applications. So architects have a different client-based application than, say, you as a security professional. So we've got a couple images here talking about like the different types of applications and servers that we have here. We would need one for, a baker, right? Here's a cookie recipe. And you can see the information here, the name, the value, the expiration date, URL, and domain. We've got our name, John Smith, phone number. Oh, error entries must be numerical, right? So we're seeing how different inputs can be validated through there, and then email addresses. So don't have a number, blah, blah, blah. So that's a part of the web application. We've got script errors that we can look at. These share sensitive information. If there's a script error, they could open to uploading bombing attacks. They open to poison null byte attacks. If you need more information on those, you can go into the book there. It'll tell you a little bit more about the bombing attacks and which you'll read it. It'll make sure, right? Uploading a lot of things all at once, and then the poison null byte attack as well. Session management. In the session management, we've got a session end not set. That's a problem, right? Weak session IDs is a problem, and password reset verification as an issue as well. Here, we'll take a look at the web application hacking. So let's just take a moment to look at our graphic here, and you can kind of see the flow chart that attacks here. So we've got to footprint the web infrastructure. You want to footprint what's going on. We'll attack the web servers, analyze web applications, attack authentication mechanisms, over to attack authorization schemes, attack session management mechanisms, perform an injection attack. We'll get to that a little bit later. And then attack application logic flaws, attack database connectivity, and attack web app client. So you can see the flow of those and just some of the web application hacking options that we have. Let's talk specifically here about footprinting. So whois lookup is something that we would use to footprint. If you don't know what whois is, look it up. No, it is just something that, we'll type into footprint the network or the server or figure out what's going on, what running things that we have. DNS interrogation, is another key one that we could have. And then port scanning as well for our footprinting. All of these are great options to footprint a server or network application. So those two would fall into the two options here: footprint web infrastructure and attack web servers. Then we'll analyze. Oh, yeah. Okay. So let's go to authentication mechanisms. So to be authenticated makes sense, right? Who are you? What are the cookies that you've used? Are you already logged in? The session IDs, the passwords that you have, these are all ways to authenticate something, which if we know that, then we also know how we can be falsely authenticated, if that makes any sense. Can we get the username? Can we get the cookies? Can we get the session ID or the passwords and then get access to something maybe we shouldn't? All right, so that would go into the attack authorization. What about attack authorization schemes? All right, this would be like an HTTP request, like you saw earlier, where we send one out, a query string, so we're looking for something, or an HTTP header, okay, looking for the authorization scheme that maybe one of these will get us through to be authorized. All right, let's talk about web application attack session management. So an attack session management, we can, talk about the session token predictions. We can talk about session hacking or man-in-the-middle attacks. I'm sure you're well aware of those. So they will fall under the attack session management. So perform some injection attacks. An injection attack would be like a code injection or a command injection. So both of those would be a type of injection attack. What about an attack application logic flaw? Well, a logic flaw would be something about their user privileges, the traffic filtering, the cookie management, all of our bullet points here, the web parameters, directory access, and business constraints. How about our database connectivity? So how are we going to attack that? We would attack the web client by cross-site scripting attacks, redirection attacks, HTTP header injections, a frame injection, or even a session fixation attack. Okay, which you can read more about a little bit later. So let's talk about this little image here that we've got. We've got our hacker. We've got a logic form. So we're gonna hack in with a logic form and do an input validation, right, to the web server. And then our firewall is going to filter packets and deny any ICMP access. So it's going to deny anything. If we can get through, then we'll look over here to the web server, and it's going to be turned off unused ports and services, and it's going to keep its patches up to date. And then, we'll filter the user input. What did they put in? So we're going to filter that out. And then if we can manage to get through all of this, then we will get access to the database with a non-privileged account. So we'll take the form, do our input validation, try to get through, make sure that we can get through the firewall, get through any of the unused ports and services and any of the current vulnerabilities before we can get into that user input and access the database. Okay, so there's a few different little layers, if you will, right? Defenses in depth that it has. And this would be like a web application countermeasure. So information gathering, configuration management, authentication testing. These are all things we have to do. Session management, denial of service testing, data validation testing, authorization testing, and documentation. Documentation is a huge one that we need, right? Otherwise, what did we do all of that for? All right, so what about information gathering? That's going to give us our active and cached website pages, our error messages, our entry points, and our web applications. Okay, we're gathering information on these things. We'll take a look at the configuration management testing. And so what is that? Well, configuration management is like the CGI scanning, the file extensions, backup and configuration files, administrative interfaces, and coding tags and comments. What about authentication testing? Password resets, session timeouts, browser cache, password error or lockout. These are countermeasures to all of the things that we've had before, and you've seen it, right? Maybe you've worked at a job or in a school, and they've told you, "Hey, it's been 3 months. We need you to reset your password," or you're logged in as say you're logged in on our web page, and you close your laptop and you move locations to another place and you open your laptop up again and they're like, "Oh, your session timed out," right? So now you got to authenticate again. Your browser cache, something that it clears off every so often. It's in short memory. So that way that browser cache goes away and you've got to re-authenticate. Or a password error. So maybe you're designing a web page and in that you have not put in that there's a limit to the number of passwords that they can try. We could do this all day, right? Until I find a way to get in, and somebody will. So you've also probably tried to log in to maybe one of your applications and you've realized after your third attempt, oh, you have to wait until tomorrow, or you got to wait 2 hours to log in, right? You've reached the maximum number of attempts. You got to contact somebody to unlock your account, right? So at that point, these are options as a countermeasure for that authentication testing. What about the session management testing or the denial of service testing? And then the data validation testing. What are our countermeasures as we continue down this? Well, let's talk about these as our discussion. Think about these options. What is a web server? What are a web server's vulnerabilities? What are the steps in the web server hacking methodology? And what are some of the actions that you can take as a countermeasure to prevent web server attacks? Oh man, I went too fast there. We're just moving right along here to our last section, which is going to be SQL injection attacks. And I skipped the last page really quickly. I can't go back. We'll be fine. We are basically just talking about the skill section overview with performing a SQL injection attack for our last, I think, 12.3 here. So moving on Here are two key terms: structured query language, SQL, maybe you've heard it before, or a SQL injection. SQL attack, SQL injection. So SQL or SQL just stands for structured query language. Okay, what are they? So SQL is a language that is used or that was designed to request data from a database. You're basically you've just got a set way of asking the database for things. That's what SQL is. If you ever want to be a data analyst, data scientist, this is what you'll need to know how to do. How do I ask those things? Well, in the hacking realm, we want to know how to do it as well. Only we want to be somebody who's injecting this with something, right? A SQL injection is an attack that attacks a web application by manipulating the SQL statements entered into a web page. We are specifically changing these into to trick the database into giving us information. Okay. So how does it work? Well, the SQL injection will go to the server, go to the web application, to the database, and we are injecting this kind of attack in so it will give us information back out. We're not asking it maybe for one thing. We're trying to gather information here with this. So by using that SQL injection, we are getting information to get to the next point. Now, there are different types of databases that you can have. There's relational databases and distributed databases and object-oriented databases. Um, and I believe we have a database course that you can take that shows you the difference between all of these. Let's talk about a SQL injection. So this is going to target flaws in web applications. It's going to exploit the input vulnerabilities. So like select all of everybody with the name that starts with a C, right? And it's going to give me everybody whose name starts with a C. Um, and maybe that input vulnerability is not supposed to be there, but we're able to get it. And there's different ways to do it as well. We're going to use existing code that's already there that we've found out so that we're able to inject as well and manipulate that. For example, say username Bob Smith, password secret. So if I'm going to select count all from users where the username is Bob Smith and the password is secret, right? This is our SQL injection, okay? Um, this is SQL. This is the statements that they would use. And select count all from users where the username is Bob Smith and the password is secret. And so then, we're going to manipulate this a little bit and see if we can gain access to the system, right? So that's what this says. This says select count all from users where username is Bob Smith. You can see that. Now, there are different types of injections. Authentication bypass, like you just saw. Can we get past that authentication pay platform? Um, can we get some information disclosure from that? So when I get into a database, am I able to, oh, I learned there are users whose name is Bob Smith, those kind of things. Um, we can compromise the data integrity that's there, and we can use remote code execution on occasion depending on the SQL injection type. Now, these steps will demonstrate how attackers identify vulnerabilities, they escalate access, and evade detection. So, information gathering on this would be like verifying database connections, generating error messages, reviewing error messages, that sort of thing. Test for vulnerabilities, we've got function testing, static testing, dynamic testing, and fuzz testing for testing those vulnerabilities. SQL injection attack here, an in-band injection, an error-based SQL injection, or a union-based SQL injection versus a blind injection. And a blind injection would be content-based injection or time-based injections. Now, there are some advanced SQL injections that are there: enumeration, password grabbing, database transfer, operating systems interaction, and network reconnaissance is another one that is there. There is also an intrusion detection evasion. So hex coding, white space, comments, and obscure code is one of the ways that we can evade intrusion detection systems or IDSs. The most effective defenses are parameterized queries, input validation, least privileged database accounts, and regular testing. That's a huge one. So these are talking about our countermeasures. But database server runs operating system commands. Maybe we've got privileged accounts used to connect to databases or error messages that are enabled. Maybe no data validation is there as well. That's a problem. So say we have a database server running OS commands. The service account with minimal rights, right? Minimal rights. It'll disable powerful commands because it's only the operating system's commands. So none of those other commands that we have that are so nice. Privileged accounts used to connect to the database. So database connection account with minimal rights. That'll monitor traffic with an intrusion detective system or an IDS. Maybe we have some error messages enabled. So default error messages is disabled, and we use custom error messages like unauthorized access is not permitted. Some of those things. No data validation. This will limit the size of the input. It accepts only expected values and tests the content of all the string variables. Oh, dang it, I can't go back. A couple of the other things there as well. Your practice is going to be the 12.3.6 perform a SQL injection attack. So you'll actually get to use this in action. It is very cool. It ties everything we just discussed before by safely demonstrating that SQL injection in a controlled environment. So you don't have to worry about anything there. And then where was it? Our class discussions. Here are closing questions for you to reinforce why SQL injections remain common and how proper development practices prevent it. So, what is a SQL injection and why is this attack method commonly used? What are the steps of the SQL injection methodology? And what measures can you take to evade IDS? What measures can you take to defend systems against SQL injection attacks? That is it for the